Okay, I'm going to work through our school's method for division, and here we have, as a number sentence, 6,347 divided into 6 equal groups, or groups of 6, and that can also be represented in this way, 6,347 divided by 6, and you can possibly see where this division symbol actually comes from there. Those two dots represent the respective numbers, and that's the horizontal line there. It's important that children recognise that symbol for what it is and not, for example, decimal points or anything of that nature. We also use a comma to show the thousands, and that's very important. So units, tens, hundreds, thousands are in the next column. Okay, we then put those same numbers into what we call a bus stop method, and it looks like they've been reversed, but the actual calculation, of course, has not been reversed. That is what we are doing, but in our method it appears the other way around, but it's important the children grasp what they are doing. Okay, and I start off by saying, can I get sixes into 6? Yes, I can. I can make one group of 6,000s, and there's nothing left over to exchange into the hundreds. It's simply 6 divided by 6 equals 1. 6s into 3 I cannot do. I cannot make a group of 6 out of 300, so put my placeholder in and I exchange those 300s for 30 tens, making me a total of 34 tens. 34 divided by 6 will equal, I'm going to try 6. 6 sixes equals 36. That's too many, so I come back 1. It must be 5 times 6 equals 30. And some children like making a little note of that, like the running total. So 6 fives equals 30. That must leave me 4 left over. I'm in my tens column. That 4 exchanges over here. Sometimes with the younger children we say swap or trade, but exchange is the correct word to use. And so those 4 tens become 40 units, making me 47 units altogether. Once again, switching it round and using my multiplication knowledge, I can say 6 sixes equals 36. That's not enough. I can go one more. 7 sixes equals 42. 8 sixes would be too many, so 7 sixes equals 42. My running total there. And I can now see my remainder, what's left over between these two numbers, 47 and 42. My remainder must be 5. And in year 5 and year 6, it's really important that children understand and learn what the remainder can mean in a real life context. For example, here, if we were working out how many coaches or of something similar were needed to transport children to a theme park or a day out, 5 left over, they would have to have a coach. There might be a lot of empty seats, but that's where that real life understanding comes in. Okay, and this would be a typical year 5 problem. Up to 4 digits divided by units. For upper year 5 and in year 6 they would also be expected to divide by tens units. For example, dividing by 12 would be a very good idea, because we do learn up to at least the 12 times table. So dividing this by 12 would be a year 6 and an upper year 5 objective as well. Also, for some of the high flyers who can grasp the next stage, which isn't actually any more difficult, instead of leaving ourselves with the 5 remainder there, we just continue into the tenths, hundredths, and in this case the thousandths column. And to do so, we put our placeholders in to begin with in our number that we are dividing, and we just carry on. So, like I said, the remainder 5 turns into 0.833 recurring. So we've got a final answer there of 1,057.833 recurring. So recurring meaning the 3 will go on forever if we carried on. We could of course round this to 0.83, and that would be another skill that the children would have to learn, rounding things generally to 2 decimal places. Not always, but that seems to be the key one to learn and to grasp in the first instance. So that is our method for division, and I'll leave that one on a moment, because that example where we look at the remainder in context is more important as a life skill than the one I've just showed you with the finding the decimal instead of the remainder.